Objective of an experiment is to design the amplifier and see the frequency response, that is an output with the change in frequency. So the first thing is we'll make the circuit by adding the components. We need capacitor. So I'm adding capacitor for the input. I press Ctrl R to change the direction at the input and output. And one more, we need it across the resistor. So I press Ctrl R and escape. Now I need the resistor. So we are using a voltage divider bias. The resistor at the capacitor collector, then the load resistor. Press escape. We need a ground. Press escape. Then we need voltage source. For voltage source, go to the components, type voltage, press OK. I need an input voltage source and a biasing voltage. Press escape. Now I need the transistor. Transistor is an SPN transistor. And press OK. Add it and press escape. I added all the components required. I'll be using the wire to make the connection. We'll have to add one resistor across our emitter. So I'll just take one more and add it here. Escape. I'll just drag the connection so that I can include everything. Press escape. Again, I take the wire to complete my connection. Now my connection is complete. You can just we have made the connections properly. See, there is a no balance. I'm connected, so I'll just redraw it. So my connections are done. We just need to be careful that we do not miss any connection. Press escape. Once this is done, we will just assign the values. So the capacitors at the input is a 10 microfarad. Or the output is again a 10 microfarad. Just take your mouse to the component that for which you want to assign the value and right click 47 and press OK. Now the resistors are assigned the value. Similarly, I take a mouse, right click and enter the value. Right click, enter the value and press OK. And the output is again a 10K. So I've given all the things that I have to add is a voltage. So input is a sinusoidal. We keep the amplitude as 1 K. And here, since we want to do the AC analysis, for the small signal AC analysis amplitude, I just enter 1 and press OK. So source become AC, that it will have a component whose frequency can be varied. Now the DC biasing voltage, I'll take it as 15. Now the last thing is we need to select which model of the BJT that we are using. Just take your mouse, right click, pick new transistor. The one that we are using is BC547C and press OK. So now we have assigned value to all the components and given the model number also to the BJT. Now we are ready to simulate. Go to simulate. Now we are doing the AC analysis. Click on AC analysis. Type of sweep will be decade. Number of points per decade be 10. Start frequency be 10. And end frequency is say 1 mega. So we can write 1 mega as, or let's keep it as 10 to power of 8. It can be written as 1E8 and press run. Now the terminal where we want to see the output is our collector of the transistor. So this arrow we know is an emitter. This is the base. This is the collector. I just click it here. We get an output in dBs. I'll just go to the right side where we see the phase. Right click and press on do not plot phase, because we are not interested in plots and the phase plot, and therefore we get a magnitude plot. This magnitude, although it shows the output voltage, but it is also representing the gain because we have kept the magnitude of the input voltage as 1 volt. Now we have to find out what is the bandwidth. For that, just go to the variable name, right click, attach cursor, go press first and second and press OK. Now we have two cursors that are visible in this window. Now we see the peak value is 42.45. So to get the bandwidth, we have to go to the 3 dB down point. So I just take my first cursor and look at the magnitude. The magnitude presently is 41. We keep on pushing it down till 39.45. Then we take the second cursor also to align with it. We can see 39.42. Yeah. So both are aligned. We can clearly see in the magnitude of cursor. The frequency, first frequency that we see is showing us the low cutoff frequency, and this is showing the high cutoff frequency. The difference between the two will give us the bandwidth. So this is how we are able to do the frequency analysis, get the gain, that is the magnitude, that we'll be able to get the gain for this plot, as well as we'll be able to get the bandwidth. Thank you.